That's funny, right?
That's so funny.
So funny.
What? It looks like a turtle.
That's cool too. It's like okay. So today we are not going to have a traditional lab. Weather is good enough that we will be able to go up to the observatory. I don't remember what the moon phase is. That's not that I planned for today's actual lecture. But I think we will be able to see some fun stuff. Except it is too windy. So if you were there the first week, you remember that it can get really windy and then we can't see anything. The telescope's just doing that. So we will plan to do that near like 7:30, 7:45. Okay. So we'll finish lecture at 5:15 like we normally would. And then you guys can dip, go get food, do whatever you want to do. And then we will meet up at the observatory. That good for everyone? Cool. Questions, comments, concerns? Okay, you may be asking yourself, hey, I've done a lot of homework and I haven't seen any of it. It's a lot to grade. I have worked through almost all of it, but the problem is that I grade first and then I put the grades in. So there's like a pile and it's just not recorded. So it's really hard for me to give it back to you. But some of the feedback that I want to talk about. So for the definitions, I think a lot of people are getting the idea, you know, just like saying what you think the thing is. Some people put like an example sentence. Some of the example sentences are really funny. Some people don't, and I don't think there's anything wrong with not putting it if you don't want to. For the chat GPT, however, I think there is a little bit of a disconnect between what I want the problems to do versus what has ended up happening. So if you read the whole chat GPT response and you just say, yep, I agree, that kind of defeats the point. You won't get any credit for that because I'm asking why do you agree? And one thing that's really important to think about is we want to use this tool because it's going to be like a better version of Google. But if you just type into Google, is the earth flat? You will get a lot of search results that are garbage, right? It doesn't know, thank you so much. It doesn't know whether it is saying lies. Similarly, ChatGPT doesn't know what the hell it's saying, right? So we want to think about what we would think the answer is going to be, and then whether or not it gives us the same answer, right? Now that is called like looking for bias in your own answer, but you're going to assume that you're right? You're like, oh yeah, but then you read it and you're like, oh, that's not really what they say, right? To that end, I want to make sure that we're reading the whole question. So, for example, if there's a question and I ask two things, like I ask one thing and then a little bit later I ask another thing, and you only answer the first part, right? You just left 50% of the points on the table, right? Finally, having gone through a lot of the questions and whatnot, you're not gonna like this. I am feeling like we may need to have a cumulative final. Because I'm worried that the level of engagement in the homework itself is not representative of the class overall. What I mean by that is, you know, let's say you're not necessarily reading the book and you're just showing up and you just Google the thing and you're like, well, this is supposed to be like a fun class that I just take before I leave. Sure, that might be the case. But if you're not really applying yourself, then what's the point of the education, right? So I'm going to keep paying attention in the homeworks. And if it looks like it's a trend, I mean, I get it, right? You're getting close to spring break. You're like, fuck, I want to get out of here. But I'm hoping that now we're like regenerated, rejuvenized. We're like, all right, we're going to get back into it. And I'm going to give 110%, right? Otherwise, probably going to have to do it. Everyone happy with that? Not happy? Raise your hand if you're happy. It's fair. Is it fair? Is it fair? Is it fair? Okay. Does everyone want to do a final?
No.
Does no one want to do a final? I mean, the way that it would probably end up working is like to replace a couple homeworks, right? So if your homeworks are really good, then you probably wouldn't have to take the final. But if you're not really engaging in the homework, I just want to see, did you understand the material, right? Questions, comments, concerns?
Is it like the lack of detail, or is it just people are just like not engaging with the?
It's a case by case basis. In some cases, it feels copy and pasty. In some cases, it's not enough words. Right? So just like have a look at like what you're putting in, right? Because that's the only thing I'm assessing you on. Right? Everyone's getting almost 100% of the labs because you all come, you make fun things, and you toss it off roofs, right? So this is the only thing that I have to assess whether or not you're doing well in class. I would love to give you all A's. I have no problem with that, but I have to see a little bit of effort. Right? Okay. Any other questions? All right, raise your hand if Pluto is a planet. Yes, 1 planet, 2 planet, 3 planet, 4 planet. No.
Excellent.
Exoplanet? No, not an exoplanet. Exoplanet would be planets outside of our solar system. So this is it's an accurate representation just a few years ago when Pluto was demoted. It's now part of what we call a dwarf planet. So these are the big planets, and this is a baby planet. And one of the things that you can see here that's a little bit of a lie is the relative sizes. Right? Any other thing that's wrong with this picture?
I'm so close together.
There's no eyeballs. That's the one that I wanted. Okay. This was fun. This happened a little while ago. Do you see this? So that actually has eyes. That's the sun. And these are sunspots on the surface of the sun. We're gonna not do any lecture tutorials today. We're gonna cruise right through the Pluto stuff. We're gonna cruise through the asteroid stuff because technically we're behind. Remember when I crashed my car? So then we're gonna get into the formation of the solar system, and we'll get into stars, and we'll talk more about like what makes the sun look like this. But that's just fun. So in fact, there are eyes. I'm just kidding. All right. This was a cool thing that happened recently. Why? There we go.
Yeah.
So on the left-hand side, this is a surface, and then a little bit while later, we took another picture, and we saw that. What is that? It's an impact. Yeah, the one that we watched happen essentially. Pretty cool. What planet? Mercury? No. It's just black and white. It's Mars. Of course it's Mars, the best planet of all the planets. But yeah, look at all that dark material that gets blown out. Okay. Let's jump to some questions really quickly. We want to think about where Pluto fits into our solar system. We're going to talk about something called New Horizons, which is a spacecraft that we sent to go say hi. And we want to talk about what we learned about the Pluto system since. Okay. So do you know the mnemonic for remembering the order?
My very excited mother. Just
My very what?
excited mother
Mm-hmm.
just sold you nail polish.
Okay. That's interesting. That's not the one that I know, but that's perfectly fine. You can make whatever one you want. It just can't include Pluto anymore.
What is the one that you?
Nail polish.
I think it's my very eager mother just served us 9 pizzas.
I think that's the one.
Yeah.
Oh, that's yeah.
Oh, there's energetic, right? So now we get rid of pizzas and you can just use nachos. That's good. Okay. It's food. Everyone likes food. So what's the definition of a planet?
Beige flake.
Does it make light?
Maybe it does.
Okay. Am I a planet? No. Is the table a planet? Okay, so what's a planet?
Something large in scale.
Okay, large, orbiting what? Orbiting star, okay, so it's orbiting a star. Anything else? Rocky?
Okay,
Well,
yeah.
Jupiter does Is Jupiter play? No, Jupiter's not a planet? Yeah, Jupiter planet.
A large celestial body that orbits a star.
Okay, so large, what is large? I mean, I'm large, right? I'm a lot larger than an ant.
What NASA considers large.
Bigger than Pluto.
I have to be bigger than Pluto. Pluto is the cutoff.
It
Yeah.
seems like they get.
Okay, well, here's the thing, Ganymede is larger than Pluto,
But it's.
but it's not a planet. Well, it is orbiting the sun,
But if,
but it's also orbiting Jupiter.
but if.
Go ahead.
I don't know
Yeah.
how to explain it.
Oh, no, you're scratching. Okay. Yeah,
Has gravity.
yeah, I have gravity.
Oh.
Everything has gravity.
Oh. Pluto's not a planet, it's, made up of like, so that would be the comet or the asteroid and stuff versus other things, other objects like Jupiter and us that are made of other things. that are made of-
So you want to think about like composition, so it's like too icy? Okay, alright.
Has a core.
It has a core? Is that a question or just a statement?
The statement.
The statement. So because it has a core, it's not a planet, or it is a planet? It is a planet because it has a core. Okay. Some asteroids might have cores. What happens then? Are asteroids planets? Rotation rate. Okay, so you think stuff that's too close to the sun or too far from the sun doesn't get to be a planet?
That takes part of the rotation.
Okay, alright. Any other things that we can think of that would distinguish a planet from a comet versus asteroids from me versus an ant?
Could be the like. The way it orbits the sun or any kind of
The
star.
way it orbits the sun, that's interesting. Like, what do you mean by that?
Like if it's too elliptical or not.
Too elliptical, right? If it's too elliptical, it might be a comet, right? Okay. All right, I like all these thoughts. Let's put them together. In 2006. Wow, is that true?
Yep.
That's a long time ago.
I was 2.
Don't say it. Don't say that you were too. Don't do that. That's illegal. Okay. Okay, I don't want to hear. Okay, so a planet orbits the sun. Rather than a moon orbiting a planet, right? By definition, a moon orbits a planet. So there's a hierarchy, right? If you're not orbiting a planet, then you need to be big. You say, well, Mateo, that's not fair. You didn't say what big was. So big enough that its own gravity makes it a sphere. Right? And everyone's okay with these. Everyone's like, this is fine for like, 150 years. And then it wasn't fine. Stop it. I had a week where I didn't have to deal with this. Okay.
Batteries.
Yeah, I changed the batteries. They're not the same batteries. And then we just add this third piece. And it says it cleared its neighborhood and its orbit. What that means is that there's nothing nearby that it didn't incorporate into itself. And when we begin to talk about the Pluto system, we'll see that it has a very big moon that's almost comparable in size. So if you don't do enough clearing, you don't get to be a planet. Okay. Whereas we get a different word here, a dwarf planet. Okay. That is one that is still in orbit around the sun, has sufficient mass to become round, but has not cleared its neighborhood. And importantly, is not something we built. Right? That obviously does not get to be a dwarf planet. Okay? Satellites, not applicable. You build a spherical satellite, you toss it into space, and no. Okay? Okay. All other objects are called small bodies. Even though they're big. Okay. So what was the main reason Pluto was declassified? Is it A, because it was too small, B, it's too far out in the solar system, C, it's made of different materials than nearby planets, or D, its orbit is tilted? me know when you're ready. So it on 3, 2, 1. Okay, all right, we'll see. Hold on to this thought. We're gonna see all of the ways that Pluto's weird. Okay. Let's talk about the history of Pluto really quickly. Come on. Okay, so Pluto was discovered in 1930. Hopefully, no one was alive then.
You were.
I wasn't. False. That's not me. I promise. It looks like me, but it's not me. It's
You
not
had
when I had hair.
You have
Okay.
hair.
Yeah. All right. So in 1930, Clyde Tombaugh was observing in Arizona at what we call the Lowell Observatory. Big old telescope right here. That's the telescope. This is the arm, and then it rotates. And what he did was he'd look day after day, looking at the plates, and he was looking for something to move. Isn't that crazy? That's Pluto. Would you have spotted that if I hadn't pointed it out?
Yeah.
Okay. And Pluto was kind of weird, right? It was like really far out there. And its orbit was not like the rest of the planets. So let's zoom in here. This is the inner solar system. You have Mercury. Mercury is doing a weird thing with the sun. It has a very elliptical orbit. But then you have your like normal ones. You have like Venus and Earth and Mars. And like, you know, Mars and Earth, they even like are tilted sort of the same amount. They're in the same plane. It's all like flat like that. And then you look out more and Jupiter's in that same plane. So is Saturn. So is Uranus, and so is Neptune. They're all kind of in this like pancake disk where all the planets are. But Pluto's like not. So if this is the pancake disk, Pluto is like that.
Okay.
You're like, weird. So sometimes Pluto actually gets closer to the sun than Neptune does. It's very weird. So there's periods of the year when Neptune is farther away than Pluto is. Oh, okay. It's strange. We'll talk about that later. This is the history of Pluto. So there's the last time it was farthest from the sun, and that was the end of the US Civil War. So it's going slowly, right? And this is when the person who created the observatory was born. This is the person who discovered what we call the Kuiper Belt was born. This is the birth of the person who would go on to discover Pluto. And then just disgustingly, 24 years later, he found Pluto. I didn't find anything when I was 24. I could barely find my keys. And then over here you have Sputnik. Anyone know what that is? For satellite from the Russians. And here, moon landing. Pluto's main moon, Charon. And then that's the closest it got to the sun. Then we decided we wanted to go say hi. So we launched a mission at it. Okay. And it arrived in 2015. It was pretty sick. And we'll talk about the results today. And we're somewhere in between here. We're like right there. It hasn't even had a full rotation. It went from being discovered less than 1/2 of a full rotation, and then it lost its giant planet, its planet status. And they were like, you're boring. Pluto's got a lot of really interesting things. So Pluto, as it goes around the sun, it shows basically the face like this, the North Pole, and it's rotating like this, and its moon goes around it like that. So it's got like imagine like the orbital plane is there, floating around, and then you're all the sun, and it's orbiting towards you. Isn't that weird? No? Scary, okay. Okay, all right. So this means that it'll have really weird seasons. And we'll see that when we or that's maybe the assumption, right? You'd be like, well, if you're fully tilted away, maybe you're gonna have really extreme seasons, right? Now, what does seasons mean on Pluto? We'll find out. Here's the orbit that I just showed you. It's kind of weird. There's Pluto, 2016, but it's probably like here now. I'm not gonna move the dot for like 50 years, so you won't notice. And here's Neptune's orbit, right? And you think, it's gonna crash right there, right? Oh. No, why not?
It's too far.
What do you mean it's too far?
Is it like different timing?
Different
Oh, types.
timing.
Neptune's on a different part of his orbit.
Yes, they are in resonance with one another. Just like Io, Europa, and Ganymede, which all go around one another in discrete numbers. There is a resonance here where every time that Pluto is on this side, Neptune's on this side. Every. Then it comes all the way around and Pluto's over here. Isn't that crazy? So if you look at this piece here, this is a fun little, like, when you start to do orbital dynamics, you can make all these really pretty pictures. And this is what you get when you rotate the solar system in Neptune's rotation speed. So Neptune will look like it's just staying right there, right? And all the other planets, they get a little bit closer and a little bit farther. So Uranus gets a little bit closer, a little bit farther. But Pluto does this really beautiful shape, right? Sometimes comes in, sometimes goes out, goes in, goes out. Beautiful loops, right? And if you want to sell like astrology things, you're like, oh, these are sacred geometry, right? That was a fallback plan for a while. It's like, if grad school doesn't work out, I'm gonna like become an astrologer on Instagram and make $10,000 from like celebrities who don't know what they're talking about. That's how you do it, right? You make these little plots. What?
You do that now.
I know, but I don't. I have too much self-respect.
Oh, okay.
Okay.
Yeah, I'm doing really bad.
Okay, so that's the number one reason to go to grad school, I think, right?
Is there any validity to the theory of like Pluto is an escape only from Neptune?
It's gonna.
No, is Pluto like an escape moon from Neptune at one point?
It's probably the other way around. So we'll see that the moons of Neptune probably come from the same population that Pluto does. And they're a group called the Kuiper Belt. And we'll talk about Pluto is basically the first object, which is basically part of something called the Kuiper Belt. So it's the largest Kuiper Belt object that we can easily see. Okay. And its composition didn't match. So you go big, 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 slightly smaller, but still quite big, big, and then tiny baby. Right? Like not even big at all. Embarrassing if you took it home to your family. You're like, I had all these ones and then I had this one. It's like a lump of coal. So shit. I'm gonna kill myself. Oh, fuck. All right. God damn it. I'm getting back to the swing of things, okay? So in the interior here, you have these rocky smalls, right? And then you got big gas. So rocky small, big gas. And this one is small ice. But these small ice we've kind of seen before. Like we saw Io look like this, we saw Europa look like this, small ice. So it just looks like a moon. And just like you were saying, maybe it's a moon that got away, right? Problem is that it's got a very unusual orbit. How did it get there? Here's the best pictures that we had before we sent a spacecraft there.
Wow.
Pretty good, right?
I mean, it's kind of far.
What kind of geologic features do you see? Dark and light, Minecraft? I don't know what Minecraft is, so.
Yeah, it's square.
This is called pixelation. Okay, that's it's not just a what is it called? Computer game thing. So these are the actual images here, and then they map them onto a sphere so we can see some of the contrast a little bit better. Right, that's all the pixels. Well, what do you see? Honestly.
It's a marble.
It's what?
It's just a marble.
No, you can see,
Inside.
hold on, you can see a little bit more, like, cause it's really
Like
use our eyes.
there are parts where it's like a lot of light, parts where it's like very dark.
What do you like most?
Okay, so there's albedo genes, there's reflectivity genes, right? There's really places you look and you say it's dark there and it's light in other places. Think about what the Earth looks like, right? The Earth sometimes has large cloud bands and huge oceans that are very dark, versus like sometimes looking over a desert that's very like light. So you might look at it, damn, okay, well maybe there's really complex geology, right? For contrast, this is the Pluto at Hubble's best resolution. There's Earth's moon at the same resolution. So like that. So this is what the moon kind of looks like. It looks better on my computer. I apologize. I don't know why it's all fucked up there. But this is fine. This is kind of like the best map of Pluto. Okay. And in color, this is what it looks like from the Hubble Space Telescope. These are all of the different faces as they move into view. Is that what you expected? Yeah, what do you want? You want better than that? It's very far away. Okay. So let's think back for a moment, because this is the Earth. This is the moon. And this is Triton, which you'll recall is a moon of Neptune. Right? And so if we look carefully at Triton, we're going to zoom in here. This is the comparable size to the moon, but it's mostly icy, right? I should just stand here. I don't know why I just ever moved. When we talked about Triton, we did talk about Triton, right?
No.
Okay, we're talking about it right now. This is Triton. What do you see on Triton?
Blue.
Ice. Yeah, you see some icy looking stuff.
It's like dots.
Yeah, there's like dots, right?
Chia seeds.
Okay. I don't know about chia seeds. Remember, this is a planet.
Those are big chia seeds.
You have pumpkin seeds. Okay. So what does this texture look like? We're thinking about food, right? Because we're all hungry.
Yeah.
This
Like
is
the skin of a cantaloupe.
correct. This is cantaloupe skin, right? And we've seen this before on Europa, where these like icy pieces interact with one another, right? And you've also seen these dark pieces before, where you have material, say cryovolcanism, that explodes off of the surface, and then it deposits this dark material on fresh snow, which looks dark on light. Yeah, cryovolcanism. What does cryovolcanism mean?
Volcanoes that spew water and ice.
Think of. Let's recall that what does it mean for something to be a rock? You can stand on it. Have you ever stood on ice?
Yes.
Yes. And in fact, if we heat up rocks, they turn into liquid. So a lot of the same dynamics, the same sort of geochemical arguments that you could make about rocks at high temperature, you could make about liquid at high temperature.
Would it be like in like Yosemite where it's like the water, like, I forgot what it's called.
Geyser.
Geyser, there.
Yes,
Would it
yeah.
be like that?
Yes, absolutely. And let's see if I have the picture here. Oh yeah, here's a much better picture. So there's your cantaloupe. That's actually comes out pretty good, right? It's beautiful. What? You want to eat it already? We got to get you food before this class. Okay. And then you can see over here, these are coming from, oh, these are the tectonic features we already talked about. There's not a lot of impact craters because it's icy, big resurfaced. And those are the cryovolcanoes. This is, of course, a real image from the surface, right?
How did they get the camera?
Oh, I took it personally, and then I came back.
On SpaceX?
Yeah, SpaceX. Yeah, I did it over the spring break. In my okay. All right. So that's of course not what's happening, but this is an artist's conception, and this is like the geysers that you were talking about. So it's like material that comes out, it sort of falls back on. Some of it will, go off forever, and it just leaves the system, and some of it coats the surface of the planet. Okay. So what's the Kuiper belt? Well, it's a hypothesized group of objects that are beyond the orbit of Neptune. And it's kind of like the asteroid belt, but it's cold and it's icy. And so there's all these dots here. They're supposed to represent objects. And Pluto is this one right here, right? So Pluto lies in the Kuiper belt, but it's massive. Okay. You see any Kuiper belt objects? The one with the arrow is obvious, right? You see the one that doesn't have an arrow?
Is it like the period?
Whatever.
Yeah.
That one.
Yeah. That's fine.
Oh, the left,
This one here?
no, top one.
Where?
Couch. In my feelings. Yeah.
Oh, that's just a coffin, right?
Wait, what? Oh, it's just that.
So sometimes like very high energetic light will not even go through the optic, it'll just go through the entire detector from a random angle and just splash. They're called concentrate. This happens. Okay. Yeah, right now you have neutrinos going through your body. You don't even feel them. They just pass right through you. Okay, so we started finding more. So after Pluto, especially with the advent of CCDs, which are basically a fancy word for cameras, you have planet hunting teams that go out and they start looking for all of these Kuiper Belt objects. And we found more of them. So we found something called, these are not real surfaces, these are fake surfaces. That's real Pluto to scale, smaller than the moon. Interesting. There's Sedna, okay, smaller than Pluto. Quaoar, smaller than Sedna. Okay. Oh, hold on. My note here is that it's the creator god for the, I don't know how to pronounce any of this, but it's actually from the native people around LA. And Sedna is the Inuit goddess of the sea. Kind of cool. Where's this one?
Oh. Right there.
Here?
No.
I'm just kidding. I can see it all the time. So we kept finding more and more. And so this was not too long ago. So there's Aries and Dysomia. There's Pluto, Charon, Kerberos, Nix, Styx, and Hydra. That's 7 just in this system alone. Makemake, really cool name. Haumea, Namaka, Ayaka, Salacia, really cool name. Orcus, Sedna, and Quaoar. Now you'll notice these sizes are kind of comparable, right? Because Pluto and Eris in size, they're actually quite similar. In fact, Eris is a little bit larger than Pluto. So if Pluto gets to be a planet because of its size, Eris has to be. Right? Yeah, and Haumea actually is kind of oval. So it definitely doesn't get to be a planet. Because what is the second definition of a planet?
Spherical.
Spherical. This is not round enough. That's more of a, okay? And there's the Earth, to scale at the bottom. Okay. So this was the beginning of the largest known Kuiper Belt objects, and we're going to see more and more of them as we go. But here's all their orbits. They're kind of all like, they're all drunk. So everyone here is orderly, orderly single file line, all going around in the same direction. And yet over here, we have all of these ones that are kind of going up, some are going down, some of them are going backwards. It's all very disorderly. It's very unusual. Okay. And they kept finding more. So these ones, you stop being able to just name them. Where? Yeah, wow, you can name it whatever you want, I guess. There's chaos. Any other things that are fun here? Pluto and Eris.
What's up with Tahar?
This one?
Yeah.
The name? I messed up the one that was shorter than Sedna. Yeah, I don't know how to say that. I can say that probably. Typhon. I don't know.
Typhon.
These ones are fun to say. Haumea and Makemake are fun to say.
Big thing.
No.
Oh,
Okay. All right. So there's thousands of them. And they're all really different. And they have totally different colors. The scales here are accurate. The average color is kind of accurate. So some of them are really red. That's weird. Some of them are really reflective, just uniformly reflective. Right? That's strange. And more importantly, we have to think about the asteroid belt, where if this is Eris and Pluto, you have something called Ceres. And Ceres is in the asteroid belt closer to us and comparable to the size of Pluto. So Pluto gets to be a part of the game, and so does Ceres. And we'll see I don't know if we'll actually come back to Ceres later. We don't have enough time, but it's cool because it's got a little bright spot. And this is just ice on the surface.
So all of these, like everything in the Kuiper belt, is that what it's called? Kuiper belt? All of
These
them
ones
are
here.
sun. They all orbit like our sun.
Thousands of objects.
The sun is too hot.
All right. And interestingly enough, so we start looking at Pluto and we use really good telescopes, right? So this is on the left and the same image of Pluto on the right. What is that, huh?
They kind of.
What am I looking at?
Oh, you know.
You tell me, I don't know. So on the left-hand side, just imagine there's a circle here. That's Pluto. Okay. And what happens is you get some basically diffraction of the light. It doesn't look very clean or crisp coming through the atmosphere. Not very many photons. But then sometimes it has this weird bulge. Why? It's a moon. So just like if I have this drink, right, and it's behind my head, and you can't see it, for some of you, right? And then it comes out, now I get the reflected brightness both of my face and of the object. And then sometimes it's like this, and you just get the total amount here. And then you get both of us, and then it disappears again. So we could tell there was a moon in this image because it's no longer circular, right? Okay. Oh no, I don't want to install updates. Can you just let me live my life? Okay. And for comparison, here's the Pluto-Charon system. Oh my God. Oh my God. There's the Pluto-Charon system compared to our moon. So if you've ever wondered what it's like to drive across the whole moon, you just have to drive from, say, San Francisco to Boston. It's pretty small. I mean, I've done that. Well, I've done DC to LA. That's not hard. That's like 50 hours, 60 hours. 50. You have to stop a few times. You're not allowed to do that all at once. But now imagine here, you have Pluto and Charon. Right? You take Charon, you put them all the way on the edge here. Like that's like going from like Virginia to like Omaha, Nebraska. Or sorry, Arkansas. Right? That's not even that far. You could drive that in like 2 days.
Oh my God, that's terrible. Oh.
Why? Okay, this is gonna drive me crazy. All right. Oh my gosh. Okay, hold on. Let's go back and let's do this again because it wanted an update and it's not getting an update. Okay. So we talked about the phase. Let's see if that runs there. They orbit around one another. They both show each other the same phase. This is supposed to be a video, but of course nothing is going to work because the Earth is cursed. All right, never mind. So looking at from the side, it looks like, Charon is coming into view and then going out of it. So I said, here's Pluto, and it orbits like this, right? And you're all the sun. At different ports in the orbit, it'll do this. And then it'll go like that. It's showing different parts of it as it goes around the sun. Okay, that's the weird seasons. It's so large. Charon is so large compared to Pluto that Pluto does a little orbit. So just like Charon is orbiting Pluto, Pluto is also orbiting Charon. So they orbit what's called the center of mass of the system. And so they're both moving around one another. Like this. Okay. We're gonna find out. Okay, so we wanted to look. We wanted to see if it has an atmosphere. You say, that seems weird. Why would it have an atmosphere? So we look, and we look for a star. So this is us here. And we're looking at a star that's very, very far away. And Pluto then, right, goes into the star, and out of it. So this is the observation beginning. Then it goes down, it's behind the planet, and it comes back out again. Right? And we can see whether or not it has an atmosphere based on how steep this is. So if it's a hard surface, then this will be a straight line. Because it'll just have like the edge. Or if it's like soft, if it curves, that means a little bit of light was getting through before it stopped getting through. Right? It was being transmitted. You remember that word, right? Through the atmosphere. So we looked and we're like, oh shit, there's an atmosphere. What? Pluto, atmosphere.
So, like, let's say if it was foggy and kind of seen.
Yeah. So it's like you're just seeing the very top of it, and it starts to obstruct it more and more and more, right? And then you get to the surface, right? And you could pull some parameters out here. They say that the temperature is 50 degrees Celsius. That's something like minus 270 degrees Celsius. So very cold. The pressures are tiny. So if you thought that Mars was sort of a WIMP, that's 6 millibars. This is 3 microbars. So this is 3 times 10 to the minus 6 smaller than the Earth. That's small. It's not big. And so folks said to them, well, it's probably like, you got Pluto and you heat up the surface and Pluto's small. So it's not going to be able to hold on to any of that gas. And the gas is just going to boil off. But since it's so far from the sun, it doesn't have a lot of energy to leave. So it kind of just sits there. Right? That's the idea. Okay. And they said, heated atmosphere probably creates this nice big object. And they assume that like all of the ice is going to be gone. Right? It's probably rocky. Is that fair? These scientists must know what they're talking about, right? Okay. And so the expectation was that escaping atmosphere was ionized, would be carried away by the solar wind, and you'd have this sort of like big escaping atmosphere. Okay. So this is the spacecraft New Horizons. It's funny because, well, I'll go on this tangent later, but what do you see here? Aluminum foil, good. This is gold foil, not aluminum. That's why it's gold.
It's
I don't know if you can microwave gold foil, but I don't think it's possible.
I don't think you can.
This is gold foil, and this is only a few atoms thick. So this type of work that you do in a clean room, if you ever want to get into aeronautic engineering, it's instrumentation. It's very technically specific. You don't usually make more than 2 total. So it can be done with, very, very, very careful objects. What's this thing here?
Or no,
What's that?
solar
Camera?
Solar panel? So I hear the word solar panel. Where's the solar panel on this thing? Is that there? No. This thing here? It's facing the bright thing. The bright thing is the sun. Good.
Like the TV dish.
Oh yeah, so this looks like a TV dish. In fact, it is a radio receiver. Is there solar panels on this thing?
No.
No, there's not. How does it get power?
This.
We just let it go with no power.
Oh.
Oh, battery. Okay, how long is the journey to Pluto take? 1 year? Oh, okay. So you think the battery life is 9 years?
No, it has to be more than that, because, oh no, 18.
18?
That's
This is not coming back, my friends. This is gone forever. So you want to use batteries. How good does the Tesla battery get you?
Like a day.
300 miles?
Oh, well, it could be a day.
Okay, so you wanna add a battery here, and then what? Let it run for 9 years? There is no solar panel. I'm trying to fix the solution here. Aha. So the sun won't help us because we're too far away. We don't get enough solar flux. But this thing here that I pointed out earlier that looks like it has little solar panels on them, these are actually radiating fins. So in here is a nuclear weapon, essentially, the nuclear reactor. And these radiate the excess heat and it generates electricity. Batteries will not work. The amount of batteries that you would have to add onto this thing would be enormous, and they would fail. Remember that batteries are chemical. So what they do is they use a chemical potential difference in order to generate electricity. And just like everything that we build, it degrades over time. So unless you're actively creating it, like this, you're gonna lose that energy. Okay. So they designed it in 2003. Look at these really cool pictures. Nice. That's what it looked like. It's like that. They finished in 2005. So that's the dish that sends back the material. That's where the nuclear reactor goes. They spin it good. Yeah, it's called a shake test, a spin test, and a vibe test. So one of my favorite stories is, you know this story already with the screws? Okay. Not on this spacecraft, thank God. But you will never have this bad again. So what you're looking at here is what's called a spin test. They take the spacecraft, they strap it down at the bottom, these massive bolts. And you gotta shake it, you gotta subject it to like temperature conditions that are insane, vacuum conditions, everything, make sure it doesn't explode, right? So they're working on doing this vibe shake on the GOES satellite. And they usually have a couple different spacecraft in the same area. And someone says, oh, you know what, I need to borrow some of the screws. So they go and they borrow the screws from one of the satellites, and they put them on the other one, they do the vibe test, and forget to put the screws on. The next day, they turn it on and just start rotating it, and that thing just falls over and destroys $100 million worth of.
That person got fired.
Yeah, it's not working in space anymore. But that's a pretty fucked up thing, right? At least you've never done that.
I think I was screaming.
Yeah.
Yeah.
Okay.
I think I just screamed.
So there was all of these instruments. I don't think we need to go through all of them except for the SDC. This is a student dust counter that was created by grad students at CU Boulder. So look at that. You could like build it in the clean room. You put on your old bunny suit and you go. So if you like are doing soldering right now in a lab, this is a skill. You can put something into space. Oh, thoughts. Okay. So we're gonna launch on what did they launch on? I forget the type of launch vehicle. But here's what they want to do. They want to thread the needle. They want to fly in between Pluto and Charon. Okay. And they're gonna look at both of them. And then they're gonna pass through Pluto's shadow, and they're gonna look back at the sun. Sorry, at the Earth. And then they're gonna look back at Charon and see if you can do an occultation. Backward occultation. Look down. Yeah, remember when you looked at the star? Then you went behind the planet? That's called an occultation. Something passes over something else. That's an occultation. Okay. So you have only 2 hours to do the whole thing. Yeah. So the whole spacecraft, for how many years did we say it would take to get there? 9 years? For a 2-hour encounter. And 5 years of planning or whatever is before that. So you better hope it all works, right? So of course they test it as they fly by Jupiter and Saturn. Okay. Okay, just before they launch, they found 2 more moons. So we already knew about Charon. They found Styx and Nix, and then Styx and Kerberos, and then they found Hydra and Nix afterwards.
So at one point they were saying, wait, are we gonna crash into something that we can't even see? Like space is dark and there's a bunch of stuff out there. Thankfully we can. So I'll cut to the chase and say that.
Yeah.
What?
It didn't have big stuff in the underworld.
Yeah, that's because of Pluto. Pluto's the god of the underworld. Yeah. Oh, sorry, you didn't know that. Pluto here is the Greek term for Hades. The Roman term for the Greek god Hades. And then Styx is the river Styx, and Kerberos is three-headed dog. Hydra, cool. Sick. Okay. Okay. All right. I showed you this. I showed you that. Okay, hold on. Let's just do the launch because that's beautiful. So they did it. Didn't explode on the launch pad. That's always really scary, right? Like you have all your hopes and dreams, then you strap it to a rocket and you hope that the rocket doesn't explode because they do. Rockets do explode sometimes. What's that? Yeah, I mean, like every once in a while.
Yes, sir.
I mean, they explode a lot more often than like planes taking off.
Well, yeah, okay.
Okay. Okay.
I mean, there's a lot of planes.
So let's think a little bit about our planetary geology. Why we're doing this. So before we look at the moon, what do we know about it? Right? We know that it's got a weird rotation. We know that it's like small and icy. Right? What else do we know? It's orbiting one of its moons. Okay, so it has something to do with the moon. We know it has an atmosphere of some type. Right? So let's think for a few minutes. Maybe write it down on the sheet in front of you. Of the 4 primary geologic processes, which do you expect to be present? Right? Based on the things that we talked about, the size, kind of feeding, things like that, right? You ready? Everyone has their ideas? What the moon's gonna look like? You don't have to answer this. Sorry, let's go back one. Just sorry, Pluto. What Pluto's gonna look like? All right, what's Pluto gonna look like, folks? Raise your hand. Yeah. Okay, erosion, so not a lot. You're fighting. Right away. First shots and then shots fired. Okay, so pro craters and anti craters. Like cantaloupe surface. Do you like pro cantaloupe? Anyone anti cantaloupe? Not generally, just the place. You hate cantaloupe. All right, so that's the surface. But are you thinking about tectonics or are you thinking about like what are you thinking of? So I want to put them back into the 4 primary spots. Okay, we talked about impact cratering. Okay. Right, so you can have like icy tectonics. That's what you're saying. Okay, so pro icy tectonics. Anyone anti icy tectonics? It's just a different word for cantaloupe. Kind of a little bit. Okay. What about the other 2? Definitely not volcanism. So he's anti-volcano. Anyone pro volcano? You're pro. Why pro volcano? Okay. You're pro ice volcano. Sorry, you're anti rock volcano, but are you pro ice volcano? Okay. Anyone anti ice volcano? So you like ice volcano? Put them on everything. That's
Oh.
anything special. Okay, so we have volcanism covered, anything else? What's the other process? Tectonics, I think we talked about that with
Cantaloupe.
cantaloupes, yeah. Erosion, so does this have erosion?
But it's weird because it's spinning like,
So it's weird because it's spinning weird,
it's spinning weird.
yeah,
Would it be like?
yeah.
Put a foundation part about.
Oh, remember, we did say that water in any form can do erosion. Okay,
Maybe you see like erosion. You see like glaciers, you see-
okay, so it's icy, so maybe there's glaciers moving. Anyone anti-glacier? And pro-glacier?
Wait,
One?
so like, would there be? The water would be frozen all the way through.
I don't know. That's my
But
question.
isn't it super cold?
I mean, the temperature there is 50 degrees Kelvin. Is that hot enough for liquid water on this? No, no, it's not.
So,
Okay.
I don't know.
Okay. So people were doing this. I was in grad school at the time. And I had a friend who works on the modeling for New Horizons. Are you kidding me? For real? Defer forever. I'm gonna kill this computer. 12 hours. Wait, why does it say 4 hours and 6 minutes?
I think that one.
Okay. Defer. All right, sorry, folks.
could be super fun.
Okay. So basically, this was the idea of the Pluto prediction. And in 2015, it was arriving on Bastille Day, which is, I think, in June or July. So everyone was trying to get their papers submitted beforehand. Because, right, if you had some bold prediction for what the surface of Pluto would look like, and then you had it before they got there, it was published, and then they got there and it was right, it was great, right? And if it wasn't, then your paper gets ignored, who cares? Right, so everyone was putting up these bold predictions, but this was the general consensus. Most folks said, well, we would assume that it's an old, grimy looking body. It's grimy because even though it does have an atmosphere, that atmosphere is like sweeping up all of this dust. And we know in general that like old materials tend to look really red because they just collect crap, more or less. Okay, it's called space reddening, whatever. But it also expected to have lots and lots of craters. And that kind of makes sense, you know, it's an old surface. And there's no reason to believe necessarily that there's any heating source. So one thing that we forgot to think about when we thought about Triton is orbiting Saturn. That's a huge source of tidal energy. Pluto's orbiting
Yeah, sun.
the sun. And it's not orbiting anything. Charon's small baby, tiny. Right? So they're like, well, we don't really think there's going to be any source of heat at all. Okay. That was a stamp from some period. Okay. And here's sort of to your question. So if the temperature at Pluto is 40 degrees Kelvin or minus 230 degrees Celsius, what state of water do we expect to find on the surface? Either A, solid water, ice, B, partially solid, partially liquid, C, fully liquid, D, partially liquid, partially gas, or E, fully gas. You know when you're ready to vote? Let's vote on 3, 2, 1. Okay, yeah, good. Everyone agrees, right? No one liked fully gas. Why even ask, Mateo? Okay. And we used Charon on Pluto to weigh them. Are you kidding me? I'm gonna kill this thing.
Well, can I have it then?
No, because we need to finish lecture. Okay. So Pluto has a density of about 2 grams per cubic centimeter. Recall that water is 1 gram per cubic centimeter and that rock starts at 2.2. Metals are 5. So people were like, it's probably like some icy rocky bits, right? Icy rocky rock, right? Not water. Okay. Hold on, let me get to, oh God.
It's like the same.
Okay. So here's the images as we got close. Okay, this is the New Horizon images. This is the close approach hemisphere, and the opposite hemisphere as it rotates into view. So these are, the pictures are physically getting bigger because we are getting closer with the spacecraft. Okay, pretty good resolution, right?
A lot better than.
Don't be upset. How much money would you pay for these? What? $5?
$11 and half each or
$11.50 in churros. They don't accept churros anymore. NASA doesn't accept churros as a form of payment. What can I say? How much would you pay? $5?
I want them to give me money because I got.
Because you think it sucks so badly. All right.
Yeah.
All right. So here's the real image. And this is all real images. Very round. Okay, interesting. That was the sun, by the way. Hi, sun. Okay, so we're headed in. What do you see?
Brown.
Brown. And? Excuse me? No, I'm asking you. What did you see? You don't see any craters. You see what?
I think that's like in the big rig.
This is a big crater?
No, the black one.
This one here is a big crater. Okay.
It's so smooth.
Yeah, it's pretty smooth looking, huh?
Yeah.
Sandy. Okay. Anything else you notice? No, it's not that one. There's only one sun. Yeah, so notice that we're looking behind it now. We're looking at the atmosphere. You can see the atmosphere right there. On the way in, you can't see it. It's blown out by the fact that the surface is bright. Okay. Definitely features, definitely smooth over here that we happen to fly by. Okay. So let's stop and just look at this for a moment. Kind of features.
I think you also see like a little lines.
You can see lines?
Like the water.
Here?
Yeah.
Yeah. What is that? Oh, that has to be tectonics on this scale. It has to be. Yeah. Okay, go top side.
There's like a big crater.
Okay, yeah, so it looks like there's certainly crater, right? Look up here, circle. Anything else you see here? Yeah,
That old structure, the one that they said looks like an ice, like, looks more like a glacier that's just really through the whole planet.
this thing?
Yeah.
That's the part. Romantic? What's missing in the heart? No craters. All right, no pizza for you. As you can see here, there's no craters inside the heart. It's fresh. Yeah, that's exactly what's going on here. This is fresh material, resurfaced. So new that it's got to be less than 60 million years old. On the geologic timescale, that's pretty baby. Yeah. Yeah, that's a good question.
I was thinking, is that maybe gold?
So this is actually a color enhanced image to show you mineral content. This is not what it would look like to your eye. It would look like the other image you saw before, which is mostly yellow and brown. But this is higher contrast in order to point out the fact that this material up here is a real color, just has to do with the mineral underlying it. And up here, we saw this darkness here. They call that Cthulhu region. And this is Skywalker Planitia. These are not official names, but they're names that they're able to get away with. I think they've been named so far. And so in fact, let's look at the composition. This is probably what we think is going on here. It's just like Europa, it's probably like a liquid a layer of frozen nitrogen forms the crust. Then there is water ice, and then there is rock. This water ice is not liquid, it's solid. But on top of this frozen nitrogen can act in some cases like it's liquid. And here's what happens when you unwrap the whole planet. Again, this will be better when you look at it on your computer at home. This is really terrible because that's the backside when we were seeing it from far away. Whereas this is the part that we flew by, and it's actually very high resolution. Okay. So that's a higher resolution image. That's pretty good. Right? Can you see a single crater? No, in fact, people whose job this is couldn't find one. Not a single one. It's pretty cool. What else do you see?
Maybe like,
Where's the cracks?
Yeah, like under the edges.
Here?
No, the entire.
Yeah,
Blind
around there.
hole.
Yeah, what do these cracks look like to you?
Ice.
No, I know it looks like ice. It all looks like ice.
Maybe they.
What's that? Let's look closer.
right up, right up the ground. They got a moisture and stuff like that.
Oh, like those like little square, like or like triangular pieces. Okay, okay. We'll come back to that in a little bit. Do you see anything when you see it from this angle? This is obviously very flat, yeah, but what else? Mountains. Right? Where's the mountains here?
At the bottom ridge.
Here, right? And what about what's that?
Island.
It's an island. It's an island of what?
Hawaii.
No. Vacation. It's an island of ice. These are mountains of ice inside of essentially what is a lake of nitrogen. Okay, that shouldn't make any sense to you, and it doesn't make any sense to normal people, right? So what's happening up here? This is convecting. Just like miso soup. Okay, it's a very young terrain, less than a few 100 million years old. Okay, sorry, that's not very young to y'all, but that's fucking young. Okay, whereas this material here is ancient, 4 gigayears, 4 billion years old. What? Okay, and here's the craters. Someone's job. Okay.
Better be getting paid a lot.
No, we do not. We do not get paid a lot. I just get paid very little. Yep, that's not because you get paid a lot. Okay. Yes, it's because I don't save any money. Do not do like I do. Okay. So there are these ovoid shaped cells that we see everywhere. And I said this already, so now of course I have to show you the video. There's the same ovoid shaped cells. Right? What is that?
Rice. Miso soup.
It's miso soup.
Why does it look like that? Why do you like the worst picture?
I'm telling you, it looks better on here. No, it's not my fault. It's this fault. Yeah, but it looks good on my computer. It just looks bad up here. Look, I promise you, if you come around here after class, I'll show you. I'm not gonna do it. Would never subject my eyes. Okay, so in fact, what we're looking at here. Come on now. You have these probably convecting cells where the material, the liquid nitrogen, gets to the surface, it cools, and then as it cools, it sinks back down into these little holes. So it heats, cools at the surface, and then falls back down again. And we have this really beautiful sets of images. I showed you that before. That's an island in the middle of nitrogen ices. So this is a water mountain. Who knows what it would be like to climb that? We'll never know. Yeah, all of these photos look better on my computer, so you should absolutely just download them. They're just not, I don't know why they're not showing up well through the HDMI cord, but this is icebergs here. You can see how tall they are. They're massive. And this is kind of equivalent to places that we see in Antarctica. A rock sticks out through water ice, right? You can see even the flow of this nitrogen ice. Someone talked about glaciers. Bada bing, bada boom. Right? What's that? What's that? hit?
Or water.
Water bubble. Yeah, so in fact, this looks like an extinct water volcano. Excuse me? Yeah, yeah, that's what I thought. Okay. They call it Right Mons. So this is probably a cryovolcano that has gone extinct. It's not actively going off. And that could be for any number of reasons, right? But the type of shape here is certainly not an impact crater. And, you know, it could be a sublimation pit, but it's not likely to be. What is that? Good, yeah, that is where the sun is setting. What else do you see? Ridges, yeah, I see some ridges. What else do you see? Does it look feathery to anyone?
Is it
Or
like water?
scaled? Yeah, these are dunes. This is scalloped dunes of sand and ice. Yeah, that's correct. That's the right way to think about it. These are dunes. And these are sublimation pits.
They look like footprints.
They do look footprints, but these would be massive, right? You would fall into one of these. Okay, we're running out of time here, so I just want to show you. This is I showed you this before. This is a backlit image. These are the size of the mountains. What else do you see not on the planet? Not on the planet. Do not look at the planet. What do you see?
Oh, like the little ring.
What's that? Layers. Yeah, what does that mean? There's atmospheric layers, and we know that they have to be very calm. Right? You can't get layering like this if the whole atmosphere is all turbulent. So you have a very calm atmosphere. And you have haze layers all the way up. Lots and lots and lots of them. Usually you only have a couple haze layers on a planet like the Earth. Right? So that kind of makes sense. It's cold. There's not a lot of energy to drive the atmosphere. But the atmosphere is absolutely visible. Right? What's that?
Like what color in the sky?
I don't know. That's a very good question. I would assume like dark blues and purples. Yeah.
Would it be like kind of dim? It's on it.
Well, yeah, you have to remember that when you're out at Pluto, the sun just looks like a very bright star. It doesn't look like the sun. You've lost most of your energy. You're not even getting really warm while you're standing out in the sun. You put your hand out like this and you're like, nothing, right? So this is the size of Pluto's atmosphere compared to Earth. Kind of weird when you think about it as a whole. The entire atmosphere is as big as the Earth, whereas the planet, of course, itself is very small. And I say planet, you're gonna excuse me. Okay. All right, and there's the final image. We can talk about Charon, but I'm totally out of time. You can also look at it in the slides. It's a lot less interesting because it doesn't even have an atmosphere. Any questions? Yeah. Yeah, they're icy. They're icy. Right, yeah. So everything that's forming, we'll talk about the formation in particular, but most of the material that forms in icy comets is also being found here. Any other questions? Okay, folks, I will see you at the observatory at like 7:30 or 8. Okay.